Alright, in this video we're going to talk about some naming and creating formulas for binary ionic compounds. In terms of just creating formulas, we're going to do the crisscross method. And so in the crisscross method, I write the symbol and charge of the positive one first. In this case, the positive one is going to be sodium. So sodium is Na, and its charge when it is oxidized is +1. Chloride is going to become chlorine just as an element, and so that's C with a lowercase l, and its charge is -1. And so if I crisscross these charges to put just the value of those numbers, I now get sodium 1, chloride 1, because a 1 goes from the sodium to the bottom of the chloride. The 1 from the chlorine goes to the bottom of the sodium. And if there's a 1, I can just basically not write it. So at the end I just get NaCl, and that ends up becoming like table salt right there. Here's another one. Magnesium oxide. So magnesium is going to be my positive, and its charge is 2 plus, or +2, whichever way you write it. And oxide refers to oxygen. Oxygen's charge is 2 minus. And so if I crisscross these, just the values, not the charge, I end up getting Mg2O2, because the 2 from the oxygen goes to the magnesium, the 2 from the magnesium goes to the oxygen. But in this case, I can reduce these because they're the same number. I can reduce those because they're basically in proportion with each other to just MgO, magnesium oxide. Next page here, lithium sulfide. Again, lithium is going to be +1. Sulfide is going to refer to sulfur, which is going to be -2. Crisscross those. I end up getting Li2S. And technically I could put a 1 after the S, like that, and it would be the same, but I'm going to undo that because I like to not have numbers for the ones with 1. Copper 2 chloride. So now these, the ones with these Roman numerals, the Roman numeral is the positive charge. Okay? So on copper, copper is Cu, and if it has the Roman numeral 2, it is a +2 charge. Chlorine, as we know, has a -1 charge. Crisscross those. You end up getting copper chloride, and the 2 from the copper went to the chlorine over there. So now I'm given the formulas and I'm looking to name them. And in naming, I am always taking the whole name of the positive ion. So the positive ion is lithium here. So that's on its own in its own word, and then there's a space, and then I take the -1 and I take sort of the base of the word and add "ide" at the end. So F refers to fluorine, and so for that I'm going to basically take the base of it and add "ide" at the end to make fluoride. So here I get lithium fluoride. For the next one, my positive is B, which stands for boron. Second one is also F, so that'll also be fluoride here. So that's boron fluoride. Okay? Even if there's a number in the compound, you don't need to talk about it at all. So you don't need, all you need to know is what is the positive, what's the negative, add "ide" at the end of the -1. Let's look at this here. here I have copper, and I know the copper is going to be one of those metals that gets a Roman numeral with it. And if I want to figure out basically what Roman numeral it will have, I can sort of go backwards. For example, I can write this as Cu1F1. And if I basically uncrisscross these, I get my copper having a +1 and my fluorine having a -1, because I know fluorine will be negative, and it makes sense. Fluorine is usually -1. Copper can be +1, +2, and so here I know, in this case, it'll be +1. So that way, when I write its name, I can have copper, and then a Roman numeral 1 here, fluoride, as the name of this ionic compound. In this case, I can do the exact same thing, basically go backwards. If I uncrisscross these here, I get copper with its +2 and nitrogen with a -3, and again, that makes sense. If I look at my periodic table, I know nitrogen will normally form a -3. And so here, when I go to name it, I can say copper 2 nitride.